Back, everybody. We are starting chapter 5, and we're going to talk a lot about polynomials. So what is a polynomial? It's some examples. This is a generalized one, but something like y equals 2x squared minus 3x plus 1 would be a polynomial. We would call this a second degree polynomial. The degree is the largest exponent, so this is the degree. Degree n. And this is a fancy way of writing that. This is the Greek capital letter S called a sigma, and it means to sum up. It's also referred to as summation notation or sigma notation. And it starts with k equals 0. So k sub 0, x to the 0 is 1, so that's right there. When k equals 1, we get x sub 1, x to the first power, that's right there. Notice we're adding them. When k is 2, a sub 2, x squared is right there. And so on, and we keep going and add them all up until we hit n. So there are basically 4 cases as far as the behavior of a polynomial, depending on the exponent, the degree, the largest exponent. And we want to know what's happening as x goes off to negative infinity and positive infinity. Well, if the lead coefficient is positive, like it is here, then it's going to start up, come down, do its thing, and then end off to infinity. If that lead coefficient is negative, then the opposite's going to happen. It's going to start down, come up, do its thing, and then end up coming down. If the degree is odd, then the opposites will happen. So with a positive lead coefficient, it starts down, comes up, does its thing, and then ends up going up. When that lead coefficient is negative, the exact opposite thing is. We're here, it comes down, does its thing, it ends up going down. And I'm going to keep this one handy because it's very useful for some other things we're going to be doing. All right. So we're going to graph the base graphs. We just have an idea of what they look like and talk about what their behaviors are going to be. This is f of x equals x. We could look at it as slope-intercept form, where the slope is 1, the y-intercept is 0, meaning it's crossing right through the origin. F of x equals x squared. This is an even exponent, and by the way, this is an odd exponent, right? It's 1, so it's actually starting down and ending up, and you can see it starts down and ends up. This next one, x squared, is even, and the lead coefficient is positive here. It's a 1. So it's going to start up and end up. So this graph looks like this. It bounces off the origin like this. It's called a parabola. X cubed, positive lead coefficient, odd exponent. That's going to start down, do its thing, and then end up up. So this one looks like this. So that's x cubed. We have x to the 4th power. Now, this one is going to look very similar to this one. However, it's going to be a little bit steeper, and then it kind of flattens out more so, and then shoots more aggressively up between -1 and 1. X to the 5th is very much like this one, but it's much more coming from here, and then it's almost a straight line, and then it goes down a lot faster. X to the 6th is even more so like this. It's almost comes down and it's almost a straight line as looking at this. I'm over exaggerating these, but I think you get the point. So let's talk about graphing polynomials using their zeros. And we'll get to multiplicities here in a second. So we're going to solve this equation, and you can see I'm going to set each of these parts equal to 0. X minus 3 equals 0. Add a 3, I get x equals 3. So the solution to this equation is 3, 4, and 5. Now, if we were to ask for the zeros of this function, it means exactly set this whole thing equal to 0. So these are exactly the same. If we were to say find the x-intercepts for this function, it means exactly find the zeros or set the whole thing equal to 0. I'm going to write these as points though. So this is 3, 0, 4, 0, and 5, 0. And we are going to find a polynomial function with zeros at 0. So x equals 0, at 5, and at -3. And what we're going to have to do to make them zeros is get the whole thing equal to 0. So -5, -5, +3, +3. So x minus 5 equals 0, and x plus 3 equals 0. And you can see that we have our zeros. So this function is going to look like this. F of x equals x times x minus 5 and x plus 3. Now you might notice that the signs are exactly opposite. That always happens because exactly we have to add it to the other side to get it. So there you have that. Keep that handy there. Let's talk multiplicity. Multiplicity are the exponents that you see. So the 0, that's x to the first power, so it's multiplicity 1. The x plus 2, that means the 0 is -2, has a multiplicity of 3. And so when it's an odd exponent like this, these are going to cross through. Now, on these two, because they have multiplicities that are even, that's these last two here, these are going to bounce. Let me show you what I mean by that. So let's put down our zeros. -2, 0, and 1. So for this first one, the -7, it has an even exponent. So the graph is going to do this. It's going to come down and literally bounce off of it. So it's going to come down. Oh, and even before I do that, the degree is if I add all the multiplicities up. So when I add 1 plus 3, that's 4, plus 4 is 8, plus 2 is 10. So this is an even degree, and its lead coefficient is positive. So I want to point out very quickly, even lead degree is positive, so it's going to start at infinity, positive infinity like this. It's going to come down, do its thing, and then go off to infinity again. So for the -7, it's going to come down, and it's going to bounce off. And when you hit the -2, because it's third power, it's going to come here, and it's going to kind of slither through. At 0, it's going to cross just regular straight through. And the 1 is an even, so it's going to come here and it's going to bounce off. And you can see its end behavior is up and up and up, as predicted. Now, I want to point something out that maybe you can't even see it with mine. Because it's a second power, it literally just bounces off. Now, this one, because it's multiplicity 3, it more snakes through. Let me show you what I mean by snaking through. Kind of like it snakes. So it doesn't go straight through like this one does. It kind of snakes its way through. And it's probably hard to see, but I tried to show it just a little bit. The 0 is multiplicity 1, so it literally just goes straight through. And here, because it's fourth power, it's more flattened out. Kind of like I tried to over-exaggerate here. My drawing isn't so great, but because it is fourth power, it is going to be a little bit more flattened out at the bottom there. I know, it's a little much. All right, part 3. More on graphing polynomials using zeros and multiplicities. So now we have a function. It's already factored for us. It's very, very nice. And we are going to mark up where our zeros are. So we have a 0 at 0. We have a 0 at -3. I'm going to over-exaggerate this a little bit. -3. And at +5. All right, now notice we have multiplicity 1. So at 0, it's going to just cross straight through. At -3, we're going to get a bounce. And at 5, it's going to slither through. Now, kind of like how that x cubed that I showed you before. Let's figure out what degree this polynomial is. First power, second power, so that's 3 plus 3 is 6. Positive lead coefficient, So once again, I expect it to start up and end up. All right, so let's use green. So we are going to bounce on the -3 because it has a second and multiplicity of 2. So it's going to come down like this and just bounce off. Then it's going to come down and go through 0, just regular go through 0. And then it's going to go through 5 because it's cubed. It's going to kind of, and I'm going to over exaggerate it, kind of slither through. So we're going to bounce. We have one go straight through. And then at 5, it kind of does that x cubed kind of slither. Probably not the right word. Always call it that though. All right, next up. All right, example 5. So we're gonna do another one. Now notice the lead coefficient here is negative. And let's see what degree we have here. We have 1, 2, 3, 7. So 7th degree. So this is an odd degree with a negative coefficient. So odd degree, negative lead coefficient. So we're going to start up and we're going to end down. And let's put down our zeros here. So it looks like we have one at -5. We have one at -1. And we have one at +1/2. All right, so we're going to start up, and when we hit here, we're going to bounce off of it. And I'm going to exaggerate a little bit. It's going to come down and then almost flatten out and then come up again. At -1, it's just going to go straight through. And at 1/2, it's going to bounce. And as expected, it started up and ended downward. So here, because it's 4th power, it's not quite the nice, pretty parabola. It kind of mushes out just a little bit down there, comes around, goes straight through the -1. And then at the 1/2, because it's squared, it just bounces off. All right, example 6. Graph the polynomial function with the following characteristics. So lead coefficient of -7. And we have, remember, it's going to be the opposite sign for these. So let's see if we can come up with this. So f of x equals -7. Start there. And so we're going to have x plus 4 with a multiplicity of 4. We're going to have x minus 3 with a multiplicity of 2. And x minus 7 with a multiplicity of 3. So let's see what we have here. So let's see what our degree is. So that's 4, 5, 6, 7, 8, 9. So it's odd again with a negative lead. So it once again is going to start up and end downward. So let's put in our zeros. So we have -4, we have +3, we have +7. All right, we'll do purple for this one. All right, so at -4, we have multiplicity 4. So that, again, it's odd, pardon me, it's a 9th degree polynomial. And it's going to bounce. So it's going to come down. Remember, odd with a negative in front, it's going to start up like that. So again, it's going to come here, bounce with a little bit more of a flattened out. It's going to go through the 3. Actually, it's not going to go through. It's going to come here and it's going to bounce off. And then it's going to slither through 7. All right, so this is a little bit more flattened out. This is a little bit more of a slither. So because they all have multiplicities more than 1, nothing just goes straight through. But I think you get the idea. All right, example 7. Form a polynomial whose zeros and degree are given. Don't expand, meaning we don't have to multiply everything together. So it's degree 3, but we have zeros here. It looks like there's no multiplicities here. So let's do f of x equals, remember it's opposite sign. Now, notice it says form a polynomial. So because we don't know what a is supposed to be, I'm just going to make it a 1. So this is going to be x, remember it's opposite sign, x plus 2 times x, oops, I'll rewrite that with the x in front, and then x minus 4. So let's call this f of x equals, whenever the x is by itself, we usually try to write it out in front like that. X plus 2, x minus 4. And because they say don't expand, we are done with that one. So for this one, we have a 0 at -2. None of them at 0, so I don't have to worry about that x going first. So we can just jump right into it. So let's call this one g of x, just because we can. So we have a 0 at -2, which means that x plus 2 with a multiplicity of 3. X is going to be 1, so that's x minus 1, remember opposite sign. And it's a 4th degree polynomial, so we don't have to force anything else. Perfect. So this is 1, 2, 3, 4, so we're done. And now we're given a graph, and we need to find a polynomial. So let's see that we have zeros at x equals -2, 0, and at 3, it looks like multiplicity 2, because it bounces. All right, so here we go. F of x equals, I'm going to put the 0 in front. This would be x plus 2 with no multiplicity, and then x minus 3 with a multiplicity of 2, it looks like. So it just takes a little bit of practice. Even if this is new for you, just watch it a few times. It should start making sense, hopefully. Thanks.